Okay, let's get started. Today I'm going over 3.6, 7 and 8. Remember from 3.3 we were learning about finding relative maximum, minimum, absolute max minimum, and finding the concavity down, out, those kind of things. We used first and second derivatives to find those things, right? Now here we are going to apply more differentiation. So let's look at 3.6. In 3.6 here we are going to use differentiation to graph a function. You already studied graphing functions, but here we are going and looking into detail by using the derivatives and all. Okay, so we follow these 8 steps to graph the function. Okay. So first of all, identify the domain if you are given a function fx. Then find x and y intercept and look for any other symmetry like even function, odd function and all. Then number 4, check whether is there any vertical or horizontal asymptotes. Then try to identify the increasing and decreasing intervals and locate local extreme values. Local extreme values means could be maximum or could be minimum. Then find the intervals of concavity by using second derivatives you learned in 3.5, 4 and all. Then finally look for any inflection points. Remember you learned in 3.4 how do you find inflection point? To find inflection point, you need to set the function double derivative to 0, second derivative to 0, and find possible x values, or find some x values where function double derivative does not exist. Okay, does not exist. So this is like you learned in chapter 3.2 and all, finding relative max min. You were setting their first derivative to 0, right? Or you are looking for the points where first derivative does not exist. Those are the steps you use to find the critical values. But to find the inflection points, you have to set second derivative to 0 and solve that equation for x, or find any other x values where f second derivative does not exist. Okay, so these are the 8 steps now you have to look at when you graph the function. Okay, so these are the things you learned here, by using the differentiation applications. You could do these things from 5 to 8 steps, finding interval of decreasing and increasing, finding local extreme values, finding intervals of concavity, and the finding inflection points. So these all now we are going to find by using what? Differentiation. Look at the first example. Sketch a graph of the cubic function fx, which is given by 1/3 x cubed minus 1/2 x squared minus 2x plus 3. So like you did in college algebra, so you could perform first 4 steps easily. Finding the domain, you already know how to find the domain. Remember, this is a polynomial function. Polynomial function is very good throughout the xy plane. So you will have a domain all the real numbers. That's why you see here R means the domain is nothing but all the real numbers from negative infinity to infinity, right? That's the meaning. Then look for any y-intercept or x-intercept. So you already studied about finding x and y-intercept. So if you set x0 and finding possible y's, then it's going to be y-intercept, right? So finding x-intercept is not easy here because this is a cubic equation. So we will omit that part. We find only y-intercept. Function has no symmetries. So that means this function is a cubic function. Cubic function is, cubic function only the first leading term, but remaining all kind of, combined together. So you will not find any symmetric properties for these fx. So how do you find the asymptotes? To find, the horizontal asymptotes, remember we don't have any vertical asymptotes because this function is very good throughout the entire domain. So you will not find any bad points for the function. But you could check whether is there any horizontal asymptotes. Remember finding horizontal asymptotes you learned in college algebra. If you want to check the function having horizontal asymptotes, simply you have to look for good y values when x goes to infinity, right? Plus or minus infinity. Do you find any good y value or finite value? Then that is going to be horizontal asymptotes. But in this case, you won't find, right? When x goes to infinity, you will get the polynomial function, which is also going to be infinity. So you will not find any, finite value for y when x goes to infinity. That's why there's no horizontal asymptotes for this function fx. The reason is here. Okay. You have to have here finite value if there is horizontal asymptote. Now let's move on to the important part from 5 to 8. How are we going to find the interval of increasing to decreasing? Well, first of all, you should know the critical points, right? Remember chapter 3.123 and all, we studied finding critical points. To find the critical points, first you have to find the first derivatives and set it to 0 and solve for possible x values. So this is the step now we have here. So finding the first derivative of the function is x squared minus x minus 2. Then you could factor them, and so this step is nothing but you are setting first derivative to 0 and you are solving for x. Okay, so if you do that, you will get the first derivative function x squared minus x minus 2. I'm setting this to 0 and I'm solving for possible x values. Those are the values for the critical values candidates. So how are we going to solve this equation? This is a quadratic equation. You could use either b squared minus 4ac formula or factor. I think this is easy to factor. If you factor this, you will get x plus 1, right? X plus 1 times x minus 2, set it to 0. This will give you x plus 1, 0 or x minus 2, 0. So this will give you x is negative 1 or this will give you x is 2. So these are the two critical points, right? So after that, use the domain. Remember the domain is full set, real number. Now you know there are two critical values, negative 1 and 2. So remember in previous chapter sections we studied finding increasing, decreasing, right? Take the test value here, take the test value here, and take the test value and find the sign of first derivative. Okay, so if the sign is positive, it is increasing on that interval. If the sign is negative, it is decreasing on that interval. So those are the steps you see here. So you could check by using the testing points. The first one, we choose -2. Okay, so we choose -2. Let me change the color. Okay, so first I choose -2 here, test points, right? In the second interval, I choose 0 as my test value. And the third interval, I'm choosing 3 as my test value. So what you want to do is simply plugging all three values into, the derivative function. Remember the derivative function? The derivative function for this problem, f prime x, was x squared minus x minus 2, right? Simply plugging those three values into this function and check the sign. That is here. That is here. So the function evaluated at -2 is positive sign, right? 4 means positive. So it is increasing in this interval. And the next one, you see the negative answer for the 0 point. So it is now decreasing. And again, for 3, it is positive answer, so it is increasing. So that's why you see these results increasing and decreasing. Okay. After that, you know how to find now local max and local min. So function is having, function is having here increasing. Increasing means function will have like that. Here function will be decreasing. And again, it is increasing, right? So that means here you will get the maximum, here you will get the minimum. Yes. So the function has maximum at -1. The value is 25/6. And the local minimum at 2. Okay, so then plugging 2 into the function and you will find the corresponding y value. This is the function value. This is the corresponding x value. Okay, so these all we learned in previous sections. Why don't you go and look at them to get better understanding about finding increasing, decreasing, and local max and local minimum. Now let's move on to find the concavity. So if you want to find the concavity up or down, you should know the second derivative, right? Remember the first derivative function just now we had, which is x squared minus x minus 2. Now I am going to find the derivative one more time. So that is the second derivative, which is 2x minus 1, right? The derivative of x squared is 2x. The derivative of x is 1. So you will get 2x minus 1. Now use this and find possible inflection points. Remember, inflection points are the points where function has change of direction, right, of concavity. So now I'm setting this to 0 and checking is there any possible x values. Yes, so my function double derivative, second derivative is 2x minus 1. I'm setting to 0 and solve for possible x. Yes, I have only one possible x value, which is 1/2. Okay, that means this is the point 1/2 where concavity is changing. Okay, so now remember again, I'm drawing a real line, -infinity to +infinity. 1/2 will be somewhere here. Now this is the point where you will have different concavities up and down. How do you check? Take the test point. So you could choose the test point. So I'm choosing here 0 as my test point. And here I'm choosing 1, hold on. I'm choosing 0. This is 1/2, right? And I'm choosing 1. These are the two testing points for what? For point of inflection. So I'm using second derivative now. So plugging 0 and 1 into second derivative function, that is this function will give you two answers now. So f double derivative evaluated at 0 is plugging 0 here, you will get -1, that is here. And if you plug in 1, you will get 1, right? That means when you're plugging 0, you will get negative sign. When you plug in 1, you will get the positive sign. Okay? Remember, if the second derivative is negative, you will have concave down, right? If you see positive second derivative, then that is concave up. So down means function will be like that, up means function will be like that in this interval, right? So this is the way to check concave up and down in that interval. That's it. We are done with everything. Then you simply combine everything and try to draw a picture. So you see, now you will get this picture. So now it is very much clear that function has increasing, decreasing intervals, and the function has concavity ups and downs, and you could check the turning points, relative max, minimum, and all. So those are given here. So you could, analyze the function like this by using first and second derivatives. So you are good to draw the graph, right? That is there. Now look at the second problem, very much similar. Unlike the first one, here you will see some bad points because this function is a rational function, right? You will see some denominator part here. Remember, this is the place where function getting bad points, right? When this is getting 0, function does not exist. That's why now domain is restricted. These 2 points are not going to be good points for us. So if you try to draw a domain for this problem, there are 2 bad points, which is -2 and +2. These 2 are not there in your domain, right? Other than that, function is good. Okay, function is good. So if you want, you could write the domain in interval notation. So -∞ to -2 union, -2 to 2, then 2 to infinity. So this is the domain. The range is possible y values for the function. If you could find, that's fine. Otherwise, you could leave that part as well. But we used some college algebra, things to find the range. So if you could find, you are good. Otherwise, you could skip that one. Finding x and y intercept is now here easy. Finding x-intercept means what? Setting function y to be 0 and solve for x. So that part is now easy because your function, when you set the function y to 0, that means the numerator is going to be 0. That means you are telling that this guy is 0. Then if you solve this equation for x, you will get simply this is 0. That will give you x is ±3. So therefore, x-intercepts are going to be 3, 0 and -3, 0. That's not hard. In similar way, you could find the y-intercept by plugging x0 into the function. When x0, you will get y is 9/2. So that is y-intercept. Okay, now you will see vertical asymptotes because there are 2 points. The function is undefined. Those 2 points are going to be the vertical asymptotes, right? X is -2 and x is 2. Then you will see the horizontal asymptotes. How do you find the horizontal asymptotes? Take the function and check is there any limit value when x goes to infinity of function. Could you find any good number? or finite number, then those are the numbers going to be horizontal asymptotes. Yes, this function has one horizontal asymptote. Why it is? Did you find this guy? Limit x goes to infinity of function fx is now 2 x squared minus 9 over x squared minus 4, right? Would you find the limit when x goes to infinity? Remember in previous section 3.5, we learned finding limits at infinity, right? So how do you find that limit? Limit x goes to infinity, you could distribute inside. So you will get 2x squared minus 9 over x squared minus 4. Remember, that's a property. If you see same degree in the numerator and the denominator, I see the same degree, right? 2, 2. Then the limit function at infinity is nothing but the ratio of the leading coefficient, here 2 and 1. So therefore the limit is just 2. This is going to be the y horizontal, asymptotes, y is equal to. That's why you have that. This function is an even function, right? When x goes to negative x, you will get the even function. In other words, you see all even powers in the function. Therefore, this is an even function. So even function are symmetric about y-axis, right? This is even function. Now, you could find the first derivative and second derivative and find all the remaining things like earlier we did. So this first derivative is 20x over that x squared minus 4 whole thing squared. And the second derivative is negative 20 times 3x squared plus 4 over x squared minus 4 whole thing cube. But you know how to find the first and second derivatives you learned. So find those things and look for any critical number. Yes, you find one critical number. Remember to find the critical number. You are setting the points where function is getting 0 first derivative. So I'm setting that to 0. That means my first derivative function is 20x over x squared minus 4, 2. If you set this to 0, this will give you possible value. Remember, 20x supposed to be 0. So x is 0. This is the only one candidate for being a critical number. After that, do you find any second derivative 0 point? No. Look at the second derivative function. Second derivative function is never getting 0, right? You will not find any real number when you set to 0. Therefore, there is no point of inflection. You could not find. So, since you have one critical point, you could divide the intervals. Remember, my domain is now having so many pieces, right? So if you draw a domain, remember we were drawing earlier, the domain was negative 2 and 2 not included in your domain. Your function has so many sub-intervals, right? Okay. Now here the thing is 0 is going to be the candidate of the critical point. So you have to check those two. So that's why you have 1, 2, 3, 4 intervals, right? So now use the test points and find the increasing, decreasing, and all. It is given here. Testing points for each interval. Remember, function is undefined at these 2 points. So these are the 2 values you will get for the vertical asymptotes, right? Undefined points. Okay, so after that, you find the first derivative sign, second derivative sign to find the decreasing and concave up, down, and that is also done. And all the time I'm using 2 functions. Now remember, I'm using my first derivative function as 20x over x squared minus 4 whole thing squared, and our second derivative function is negative 20 times 3x squared plus 4 over x squared minus 4 whole thing cube. Use these two functions and try to find the sign of the function values at each interval by using the testing points. So you will get this table. After getting the table, we simply draw a graph. This is the graph you will get. Remember now, this graph has a lot of discontinuity points. Function is not defined at 2 and a negative 2, 2 and a negative 2, and you will see one horizontal asymptotes here and two vertical asymptotes, and the graph has two x-intercepts and one y-intercept, and so on. Okay, so this picture will give you all the piece of information for the given function. Okay, so you have now more work, right? Checking increasing, decreasing, concavity up and down, and so on. Okay, so please go through this problem and let me know if there is any question. Now example 3 is also same sort of problem. First you find the critical points, then you find the y-intercept, and if you find the y-intercept, that means your graph is going to intersect y-axis at that point. If you can't find the x-intercept, that's fine. So you could skip that part. So find the first derivative and set it to 0 to find the possible, critical values. The question is, we are drawing the graph for 0 to 2 pi. Okay, after that, you could extend that function outside. So again, same thing, setting to 0 and solve for x. So you study trigonometry. We need some trigonometry to solve this equation for x, because these are trig functions, right? So please go through trig functions, problems you learned earlier to solve the equation. Okay, so the first derivative function here is 2 cosine x plus 2 sine x times cosine x. Now what will happen if you set this to 0 and solve for x? Well, you could factor cosine x here and there. Not only cosine x, 2 cosine x. So then you will get this. I'm solving for x, therefore possible values cosine x could be 0, or 1 plus sine x could be 0. Then you find the possible x values when cosine x is equal to 0. So the possible x values are going to be pi over 2, 3 pi over 2 on the interval 0 to 2 pi, okay? You first draw the picture for 0 to 2 pi. Here, sine x supposed to be negative 1. Here, possible x value you will get just 3 pi over 2. Again, on the interval 0 to 2 pi. So I found 1, 2, 3. 3 possible critical values, right? After that, draw the domain. Remember, we are drawing the picture for 0 to 2 pi first. So what are the possible candidates? Yes, I see pi over 2, 3 pi over 2, right? So pi will be somewhere here. Pi over 2, 3 pi over 2. So that's the way you have to split the intervals, right? Like that. So there are 3 intervals, and to test the value with some, possible non-values and find the sign of first derivative. So you will get this result. So first derivative evaluated at pi over 4. So what are the testing points now we are using? We are using 3 testing points. One is I'm using the test points in this interval as pi over 4. Here I choose pi as a test value, and here we use 7 pi over 4 as a test value. So plugging these 3 values into your derivative function, remember the derivative function that is here. This is the derivative function, right? So remember the derivative function. First derivative function is 2 cosine x plus 2 sine x cosine x. Simply you have to plug in those 3 values and check the sign. Okay, if you do that, you will find the increasing decreasing interval, and it says that function is increasing on the first interval. That means you should get positive. So here also positive, but the middle side you have to get the negative. So that's why function is decreasing. So you could check those 3. Okay, once you know that, remember one is increasing and decreasing. This is decreasing and increasing. So here you have maximum function, and in this interval you have minimum function. Yes, so these are the 2 values that is here. Then after that, use the second derivative and find is there any inflection point. So if you set the second derivative to 0, then you will find so many point of inflection. There are 3. Okay, after that you could check the sign for each value like earlier you did, and you will get these results. Now this is your task. Could you check this? How do you check? Take the entire domain 0 to 2 pi. Now I'm checking is there any concavity changes. So I'm talking about now second derivative. So if you set the second derivative to 0, there are 3 points you will get. These are the 3 possible candidates for inflection points. So I will check pi over 6 will be somewhere here. 5 pi over 6 and 3 pi over 2. So now you will break into 4 intervals, right? And test the points for each interval. Testing points. Okay, so according to your note, what are the points we have chosen? Testing points. You could choose any value here. Okay, you could choose any value. Choose one value here, choose here one value, here one value, and there one value. You could choose any value. Remember, pi over 6 means 30 degree, right? So you could choose any value within 0 to 30 degree and plugging into second derivative function. Remember, our second derivative function is negative 2 sine x minus 1 sine x plus 1. You simply plugging those test values into this function and check the sign. Check the sign. Okay. So you should get here positive sign. Here you will get the negative sign. Then again here positive sign. And here also positive, I believe. Okay, so this is the picture. Then this will tell you the story. After that, combine everything and draw the plot picture. Okay. Now I'm leaving example 4. You could try and check whether You understand these things. So let's move on to 3.7. So 3.7 is about using derivatives, application of differentiation to do the problems with optimization techniques. Look at the first problem. A manufacturer wants to design an open box having square base and the surface area should be 108 square inches. What is the dimensions will be for a box to have a maximum volume? So your question is, you need to find out the dimension of the box. We don't know, right? So you need to find possible x values and the height of the box. In order to get the maximum volume, what will be the x and h? But only the condition was the surface area is supposed to be 108. Remember, there are how many faces here? This box is open box, right? You see only 4 side, surfaces and the bottom. Totally, there are 5 faces, right? So this is the formula you will have if you model the formula for the surface area. One is for the bottom area is x times x, which is x squared, and you will see 4 faces, rectangular faces, right? Length is x, height is, height or width is h. So when you multiply, you will get x times h. This is just the area of one face. There are 4 of them. That's why 4 times xh. When you add those two, you will get total number of total surface area of all 5 faces. That is supposed to be 108. So basically, you are given a constraint condition, right? This is the condition. The question is, with maintain this condition, what will be the x and h answer in order to have the high, or the higher volume? So I'm writing the volume function here. Remember, the volume of the box is nothing but base area times the height, right? So the base area is x squared times height. So this is the volume formula. Okay. So you need to find the x and h to get the maximum volume, right? So how do you find x and h? But only condition is this, and the volume should be maximum. Isn't that? So first of all, if you look at your volume function, there are 2 variables, x and h, right? So we need to change these 2 variables into one variable. Change into one variable problem. That means I'm going to get rid of h. How? By looking at the condition you have. So what you want to do is solve the condition equation for h and plugging into here for h, and you will get all the terms in x, right? So that's the work here they have done. Solving this condition equation for h will give you 108 minus x squared over 4x. Now you could plug in those values into this function, so you will get the new volume function in terms of only x, which is 108 subtract x squared over 4x. So I'm plugging these values for h, right? After that, now you have the function all in terms of x simplified. That is the simplified version. Now this function is only having one variable. Now you know how to find the maximum and minimum. So this function has maximum value. First, find the first derivative. Remember the condition. This is the condition because the surface area is this. I know that maximum area is surface area supposed to be 108, right? That means the maximum possible x squared is 108. So you cannot exceed 108, right? Therefore, you are giving that condition here, x squared supposed to be 108. That means x supposed to be square root of 108. So this is the condition you are imposing for x. that is here. We call that condition as a feasible domain. Now after that, use the maximum, finding maximum of the relative maximum of the function you studied, right? First you need to find the first derivative. So remember my function is now not fx, instead I have vx. My vx function is now 27x minus x cube over 4. So find the first derivative. So I'm finding the maximum value or critical value. So you know the first derivative is simply 3x squared over 4. Now setting this equation to 0 and find the critical values. So the critical values are now plus or minus 6. You will get two critical values. One will be the maximum and one will be the minimum. Remember, we are looking for the maximum volume, right? Okay. So you will get two answers. Remember the domain, 0 is here. My x value is 0 to 108, right? Possible x value, square root 108, sorry. Now I have two critical values, x is -6 and x is +6. So you don't consider -6, right? Because x cannot be negative. X is the length of the box. Impossible to have negative. So that means you will find only possible one critical value, which is 6. So now you are going to check whether function has maximum at this value. You have to check, right? How do you know? You could use either first derivative or second derivative test you studied earlier. But if you check by using first derivative or second derivative, it will give you, yes, function is having maximum at that. What is that function value? Remember the volume formula? The volume formula was this in terms of x, right? Okay. So if you plug in 0 x6 here, you will get the function volume function value. Okay. So this is the volume maximum function, and the function has maximum at 6. So this is the possible x values where maximum getting max, function get max. Once you know x, how do you find height? Remember, you need to find both x and h, right? These are the dimension of the box. Once you know x value, go back and putting into that condition function, x squared plus 4x plus 108 supposed to 4x supposed to be 108. Use this function and plugging x6 here and solve for h. Okay, so I'm using this function to find possible h value. I know x squared plus 4xh supposed to be 108. I know now x is 6 will give you the maximum. So I'm plugging 6 here for x. You will get 6 squared plus 4 times 6 times h. Supposed to be 108, right? Now we could just solve this equation for h to find the height. So 4 times 6, 24h. This is 36 equals 108. So subtract both sides 36 and solve for h. So 24h will be, how much it is? 62, right? 72. So h is nothing but 72 over 24. That is 3. So we found the dimension of the box in order to have a maximum volume, which is height is 3 and the box length is 6. Okay, so those are the dimensions. So this is very good problem, in application of optimization with the differentiation. Okay, good. Now second problem also pretty much similar. The second problem is there's an open lid box to be made by cutting the congruent. You are making the open lid box by cutting and throwing 4 square edges equal length. Okay, so the box is here. So making a box. The question is, how can this be done to maximize the volume? Again, they're asking you to maximize the volume. In order to get that, what will be your x, the dimension where you are cutting and throwing, from each corner. So again, the same procedure like earlier you did. Use the volume function and find the critical value and find the critical value where the function get max. So those are the values you have to find out. So again, the same thing. Remember, x supposed to be less than 6, because if x were more than 6, then how could you make a box? Because the maximum length is 12. So if you cut 6 both ends, you will get nothing, right? So that means your possible x supposed to be between 0 to 6. This is the condition now you are going to use for x. That means, in another word, this is the possible x values for the volume function. So again, make the volume function. The volume of the box, length is 12 minus 2x, width also 12 minus 2x, height is x, right? So when you simplify this, you will get the volume function, which is 4x cubed minus 48x squared plus 144x, right? Now this is the volume function. Again, you have to find the critical points, find the points where function get max. Those are the values now we need, right? Possible x value. So first derivative, find the first derivative of the function. That will be 12x squared minus 96x plus 144. So you could factor this. This is 12 times 2 minus x and 6 minus x. How do you find the critical value? Set this function to be 0 and solve for x. So you will get possible x values 2 and 6, right? So these are the critical values. Now we don't know which point will give you max and which one is giving minimum. You have to find out. So you could use either second derivative test or first derivative test you study to find the relative max and minimum. Okay. So this is my possible x values. Remember, my x is 0 to 6. Okay. 2 will be somewhere here. And find the sign of the first derivative. Okay. You could choose one test value. Suppose say 1 and say 3. You could plugging into your function and find the sign of that. Remember the first derivative function. The first derivative function is v prime x now. The first derivative function is now v prime x. That is v prime x is here. This is your function, right? First derivative. Now we are going to test the value 1 and 3 into this function. So if you plug in 1 here, what you'll get? 12 times 2 minus 1, 6 minus 1. You will get 12 times negative 1 times 5. Remember, this is now negative answer, right? Therefore, you will get negative in the first interval. Okay. In the first interval, how about 3? We plug in 3, we will get 12 times 2 minus 3 and 6 minus 3. Again 12 times, negative 1 times 3. So again you are getting when you evaluate for 1, 2 minus 1 supposed to be 1, right? So this is positive. This should be positive. Now you are good. So this is positive slope, this is negative slope, so function should have maximum at 2, right? Therefore, it is clear that function Vx has max at x is 2. That means if you cut 2 inches from each corner, you will get the box which has maximum volume. Okay, that's the meaning. Or using the first derivative, you could find the maximum value of the function. I will include a couple of problems from each section from your textbooks, and I will write the solution and will post in 2 days. Okay. So why don't you look at example 3? So that is your turn now, is to go through example 3 and see whether you understand that. Okay. So these 2 problems are already explained in detail. So why don't you go through? So example 5, how about this problem? 4 feet of wire is to be used to form a square and a circle. How much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area? So picture is here given. You are given 4 feet length of the wire, right? So you are going to make 2 different shapes. One is square, another one is circle. So we don't know the dimension of those 2 guys. Okay, that's the question, right? You need to find out how much length you need for each object. So you could keep x as the length of the square and r as the radius of the circle you are going to make. Okay, so the given condition is you should have maximum total area. So this is the formula you have for the total area, right? Area for the square is x squared and area for the circle is pi r squared. So you are adding both to find the formula for total area. Now this formula is for total area. In order to get the maximum total area, what will be x and r? That's your task now. Once you know x and r, it's easy to find out the length of the wire, okay? So that is the idea. Okay, like earlier we did here also, you are going to set up 2 equations, one with the constraint, another one with the area function, right? Okay. Remember, the total length is given. The total length is 4 feet. The total length of those 2 pictures are now 4x and 2 pi r. Remember, 2 pi r is the length of the circle, right? Circumference, in another word. So when you add these 2, you are supposed to get the total length of the wire given, which is 4. So this is the equation we need now as a constraint. Okay. Now we are going to change like earlier. Your basic function, area function. Remember the area function, there are 2 variables, right? You are going to change into 1 variable function. You know the relationship between x and r by using the constant function. You could solve the constraint function for x? Could you solve the constraint function for r? Sorry. So I'm going to solve this equation for r, okay? So I could subtract both sides 4x. So I will get 4 minus 4x is 2 pi r. I'm solving for r, right? So I'm dividing by 2 pi both sides. So this will give you 4 minus 4x over 2 pi. That is nothing but r, right? Now you could simplify this fraction, divide by 2 everywhere, will give you 2 minus 2x over pi. This is going to be r. So now replace the r value by this guy into that original area function. That's why you see this step. So they have factored 2 out, and they have written like this for r. 2 times 1 minus x over pi. Replacing instead of r and simplifying, you will get nice function in terms of x only. So this is the area function. After that, take the first derivative to find the relative maximum. Okay, find the relative maximum. Okay, so find the derivative and set it to 0 and find the critical value. Set it to 0 and solve for x. So you will get the critical value as 4 over 5 plus 4. So you could approximate this to 2 decimal place, that is 0.56. Okay, now you could use either first derivative or second derivative and find area for the square is 4. Okay, not area, I'm talking about the perimeter. The perimeter maximum is 4 because the maximum length you are given is 4 feet, right? Therefore, the possible maximum perimeter is 4. Therefore, the possible x maximum is 1, isn't it? You cannot exceed 1 for x, because if you exceed 1 for x, then you will exceed 4 feet of the wire. So the given wire length was 4 feet, right? Therefore, your x cannot be more than 1. So this is the possible x values you have. Now you know that your possible x value from 0 to 1. Now you see you got one critical value, which was 0.56, right? 0.56 will be somewhere here. Now check your area function first derivative you got, plugging into these test values. So you could use 2 test value. You could choose maybe any value you could choose. Okay, you could choose any value. Okay, so you could choose either 0 or you could choose either 1 here, no problem. So according to our node, we have chosen 0 in this interval and 1 in that interval. So 0 evaluated at the first derivative, and you will get 0 evaluated at the second derivative. You could plug in those, and you will check, the answers either in first derivative or second derivative at 0, right? So if you plug in those values, function value at 0 is 1.27. Function value at 0.56 is 0.56. Function value at 1 is 1. Among all three, which one you are getting maximum value? Yes, you are getting maximum value at 0, okay? Not at 4.56, so that's not correct. So you are getting maximum at x is 0, okay? This is the maximum value you are getting for the function. That means what? That means if x is 0 means we are not using any length for the square, right? You don't use any length for the square. You are using all of them to make circumference. In that way, you could maximize the total area. So that is the one you have to look for. Okay. So for this problem, you are getting maximum value at 0. So you have to look at this carefully. And your answer is supposed to be at 0. This is the point now I need. Okay. That is the point you are getting max. Okay, how about the previous problem? These two you have to work through. And this problem, we are getting maximum at 2. That is fine, right? That is correct. Okay. So what is your idea here? Making a function, use the constraint, and in order to get the maximum, you have to first take the first derivative and find the critical points, and whatever you learn the techniques, either first derivative or second derivative, apply them and find out the possible the value for given problem. Okay, that is there. Okay. Now let's move on to the last section today. This is about, again, using the application of differentiation using Newton's method. Okay, so Newton method says, suppose if you want to solve one equation, say, suppose if you want to solve this equation f(x) is 0, solve means what? You have to find the possible x values, right? To solve this method, we use all the applications of differentiation. How can I use? We use some iteration method. We use this formula, okay, to find the possible solution for the given equation, possible zeros in other way. Okay, so first of all, you need to guess the answer initially. Based on that, you have to move on to find the, a very close answer to the given equation. Okay, so you will understand if I do one problem. Calculate 3 iterations of Newton methods to approximate the zeros of the function. So you need to find the zeros of the function. Zeros of the function means you set the function to be 0 and you have to solve for possible x. That is going to be the zeros of the function, possible x values, right? Possible x values are going to be zeros of the given function. In this case, the given function was x squared minus 2. You set to 0 and you solve for possible x. But I know the answer, right? You know, answer is square root 2 for possible x, plus or minus. But we don't need that. We need to use the Newton method. Okay, so they're asking us to find the possible x values with 3 iterations. 3 iterations. Always you have to start with the guess. They're telling start the guess with the 1. So you are basically taking x1 as the initial guess. Okay. If this is the case, you have to use that formula I gave at the beginning. Xn plus 1 equals xn minus fxn over f prime of xn. The thing is, you need to find out function at xn, function first derivative at xn. So you need to find the first derivative of the given function. In this problem, f prime x, first derivative is 2x, right? Yes, the derivative of x squared minus 2 is 2x. That means I could find xn plus 1, which is xn minus what is fxn? Fxn is nothing but take the fx function, replace x by xn. So it's going to be xn squared minus 2. That is my f of xn divided by f prime of xn. F prime is nothing but 2x, right? Now they are plugging xn. You will get 2 of xn. So this is the iteration formula I have, isn't it? You know now the initial guess x1 is 1. Now, by using this, you have to find x2. How do you find x2? Use this formula. Simply plugging n1 there in your formula, you will find out x2. If n is 1 here, plugging 1 everywhere whenever you have n. So I'm plugging n1, so you will get x of 2 equals x of 1. Subtract x1 squared minus 2 over 2 times xn, x1, right? Now you know x1, initial guess was 1, so x1 is 1. Simply you plug in 1 there, and you simply, simplify this. What is this? This is going to be 1 minus 2 over 2, right? That is 1 minus 2 is negative 1 over 2. So that is going to be, what's that? 1.5, right? Positive 1.5. That is x2. So all the works are done here. Okay, you are finding f of xn and you are finding f prime xn, and after that, using the formula, we are using this formula and finding out. So you got x2. This is x2. X of 2, right? N is 2. So we got x2 is 1.5. Once you have x2, keep on moving and you can plug in the values here and find out x3. This is going to be x3 now, right? So this is x2, this is x1, and this is x3, and this is x4. They are asking us to use 3 iterations. That means you have to find 3 guys, x2, x3, and x4. x1 is given in the problem. So you need to find up to 3 steps. So your final answer is going to be x4. That is here. That is the Newton approximation answer with the 3 iteration of the given problem, x squared minus 2. Okay? You could use either table or you use like this I did, one by one you could find out. If you are given x1, find x2. Now take this value x2 as your second initial value and again use the formula for plugging n2. Then you will get x3 and so on. Okay? That is Newton iteration method. Now this problem, you have to think smartly. Question, could you find the square root 8 by using Newton method? Of course, remember, if x were square root 8, I know now x squared is 8, right? If you move everything one side, this is the simple equation. What I'm trying to say is, if this were the given equation, you are solving this equation for x means you will get x as square root 8, right? That means you are simply finding the zeros of x squared minus 8 function. So your function is now x squared minus 8. Okay? In order to get the square root 8 answer, your function fx supposed to be x squared minus 8. Now, use the Newton iteration to find out, the possible values. Okay? So look at the work. We know 3 squared is 9, right? So you could use, the initial value, guessing value as 3. Okay, so initial value, you could use x0 or x1, that's up to you. You could use x0 as well. So that is the initial guess. Now use the iteration formula. Remember the formula? Xn plus 1 equals Xn subtract f of Xn over f prime Xn. Remember your fx function. Your original function for this problem was x squared minus 8, right? Now I need to know the first derivative, which is 2x. Now if you're plugging everything into this formula, you will get now Xn plus 1 equals Xn minus, what is f of Xn? Simply take the f function and replace x by Xn. Okay. Then this all divide by f prime of Xn. F prime is now 2x, right? So which is 2Xn. Now this is the iteration formula you have. I know initial guess x0, I got 3, right? Now n is 0 means you will get this. Just plugging n0 here in this formula. Yeah. If n is 0, plugging 0 wherever you have n, you will get x1, which is x0 or x0, subtract x0 squared minus 8 over 2 x0, right? But you know the initial guess x0. X0 is 3, no? So plugging here 3, you will get new x1 value. Wherever you have x0, replaced by 3. So that is the step explained here, right? In your note. Look at here. So you simplify it, you will find x1, which is 2.83. And now use that value as your initial guess and find x2 and keep on doing. But it is enough to stop at certain, maybe a couple of steps. So you could stop at that point in x2. Okay, so your possible answer for this problem is 2.828. Okay, 2.828. That is true, right? Square root 8 is very close to that number, no? So this is about Newton iteration. It's very easy to understand. And I just want you to try and get correct answer about this problem. How many iterations we need? Question. Use 3 iterations, mean you have to find 3 answers. The first guess always you have to find out or will be given. Okay, so easy way is first you could graph the function. To graph this function and guess the first initial value. Then go from there. So picture is given. Why don't you try these two? And also I'm going to do a couple of problems here in the class notes and I will upload later this week. And you should be able to do all the problems then. Let me know if there is any question, okay?